Anyone who believes in indefinite growth on a physically finite planet is either mad or an economist.
We don't want to focus politics on a notion that involves the rejection of principles around which a large majority of our fellow citizens organize their lives.
We are not as endlessly manipulable and as predictable as you would think.
I'm honored, I'm deeply honored to be here. I'm terrified and intimidated by the expertise of the panel that's been assembled. And I'm thrilled and puzzled to have been taken so seriously. And maybe I should explain. This book comes out of many years of thinking about the puzzles and the problems that physics and cosmology faces. It presents views that I came to slowly over many years, beginning with actually the discussion of my first book, Life of the Cosmos, which already had the idea of laws of nature evolving. The background for this book is varied, but a very important element of it is a set of conversations I began to have with the philosopher Roberto Manguibera-Unger at Harvard Law School, who also, from his point of view as a social and political and legal theorist, had come to the view that we must live in a universe where laws of nature evolve and where time is real to permit human beings to have the kind of agency that we imagine we need if we're going to address the problems that we face. And Roberto and I engaged on a common project, one output of which is this book by myself, but there are other outputs in progress, papers, scientific papers, philosophical papers, in a joint book. Now, I'm going to take as evident, and I'm not a scholar, so I'm just going to assert that social thought is influenced by our cosmological ideas and vice versa, and there are many examples that scholars cite. For example, the interchanges between John Locke and Newton. And in 20 minutes I won't expand on that. But Roberto Unger and myself and some other people are proposing a large shift in our cosmological ideas, and I'll frame the shift in a few minutes. And what we're here to do today, and again, I set out this prospect in the epilogue of the book, but it's remarkable and it's a wonderful thing, I would say, about British intellectual life, to be taken seriously at this. What I set out in the epilogue is the implications, some thoughts as a non-expert. I'm not an economist, I'm not a social theorist, I'm not a politician. I'm not an expert on climate change, but nonetheless, I thought it was important to say that there were implications of this paradigm shift in cosmology for how we conceive of ourselves, for how we conceive of the future, because how we think about time influences how we think about the future, as I'll describe in a minute, and for how we think about the possibilities of solving the problems that face us, from personal issues in our family lives to economics to climate change. Now, what are the key claims in the book? And I'm just going to state them because I just have a short time. And I'm going to state first the claims and then characterize the paradigm shift that we are promoting or that we are suggesting. The claims of the book are that, one, in physics, as opposed to ordinary life, there is a belief that our experience of the present moment, our experience of time as a flow of moments, is an illusion. Einstein said famously that we who understand physics know that the distinction between past, present, and future is only a remarkably persistent illusion. And this idea that our experience of time is not real, but we live embedded in a timeless universe, the true view of which is a perspective of the whole universe through time as one, is central to physics in the 20th century. It's central to the interpretations of relativity theory, central to how we think about quantum theory, and as my friend Julian Barber set out about 10 years ago in his book, The End of Time, central to how we think about the unifications of physics that those of us who work on them study, so-called quantum theories of cosmology. Now, we oppose this, and we oppose this making a move in two steps. One of them is to argue that this idea that time is unreal, that the future is determined, and so forth, is an overinterpretation of a method, and it's a method that is very well suited to studying small parts of the universe. Where we differ and where we impose a wedge is taking this method and this characterization of nature and extending it from small parts of the universe to the universe as a whole. So that move, if you have a method which is well suited to study individuals, to study small parts of a system, whether it's a cosmology or social system, it's incorrect to just take the same ideas and apply them to the full closed system that they're part of. That's the first move we make. We then claim that in order to have a theory which can successfully answer the problems and the challenges of a theory of the whole universe, it must be one in which embraces the reality of the present moment and the reality of the flow of time. And in particular, that there be no timeless truths, that there be no laws which hold outside of time, but instead that laws of nature, as with every other natural phenomenon, evolve in time. Now, the science part is hypotheses about how they may evolve, testing those hypotheses, developing those hypotheses. That's not what we're talking about tonight, but that is developed in the book. Now, here's one way to characterize the shift that we're advocating, that we're proposing. It's in the context of naturalism. Naturalism is the philosophical point of view or the framework in which we say that all that exists is the natural world which science studies. There's no separate mental realm, there's no separate realm of the soul apart from what's part of the natural world, and there's no other worlds, like there's no mathematical worlds which somehow exist autonomously of the natural world. But there are two versions of naturalism which I think have to be teased out and opposed to each other. So I'm going to call them Naturalism 1 and Naturalism 2, or timeless naturalism and temporal naturalism. So here's Naturalism 1. Naturalism 1, timeless naturalism, holds that the laws of nature are timeless, immutable. They influence what happens, they determine what happens in the universe, but what happens in the universe does not change them. They're immutable, hence inexplicable by any means, checkable by experiment. And that's the problem with Naturalism 1. The experience of the present moment, the distinction between past, present, and future, every other kind of human experience that we value, sensation, will, agency, imagination, the impression we have that life brings forth surprise, that life brings forth novelty, are all illusions. What's real is what the atomists, the Greek atomists, called just atoms moving in a void. This is an expression of that philosophy. Atoms with timeless, eternal properties, moving according to timeless laws in a space which is timeless. Everything else being an illusion in the sense that when you get right down to it, when you reduce the phenomena to their essential parts, you just have atoms moving in a void. The future, by the way, is determined. The idea that the future is already determined from the present is part of this naturalism version 1, and survives in quantum theory, in versions of quantum theory with the quantum state. I'm saying this in case there are any quantum physicists around. This applies to you too. And then the metaphysical or mystical aspect of this is that if all of that are illusions, what's real? Well, what's real is claimed to be some, quote, mathematical reality which is timeless and which mirrors the world in the sense that the true nature, the true properties of everything in the real world are mirrored in some mathematical equation, some mathematical formula, such that anything that develops in time already could be accounted for on the basis of a mathematical computation which is carried out outside of time. Okay, so that's Naturalism 1, timeless naturalism. And that's what Einstein was talking about when he said this, when he made the quote that I quoted. That's what I was brought up in. In fact, that's what I went into physics to realize is the construction of these timeless laws, the discovery of these timeless laws of nature. In naturalism, too, all that is real in a moment. All that is true in a moment, which is one of a succession of moments. So this is temporal naturalism. All that exists is part of nature, but nature exists moment to moment to moment to moment. And everything that is real or true at a moment is such at a moment of time. In other words, our experience of the world as lived through a succession of moments is not an illusion, is not some peculiarity of our psychology, but is one of the deep insights that we have the privilege of having into the constitution of nature. Laws cannot be timeless because nothing can be timeless in this domain. Laws, there will be general laws. They will hold for some regions of space and time, but they're not absolute. They're not immutable. They evolve like everything else, maybe sometimes slower, maybe sometimes abruptly. The mechanisms by which laws evolve are what we should be really interested in as naturalists. Just like biologists used to be interested in characterizing the absolute essential properties of species until they realized that there was the story of evolution that connected all the species together, and that was the deep structure that one really had to understand, is how the species evolved. We advocate that cosmology and physics has to make the similar transition. The future is certainly predictable to some extent. Physics works for small regions of space and time, but the argument that physics is deterministic, that nature is deterministic, that the future is already present in the present, is not applicable. So the future may be partly open. Nature has the capacity to bring forth novel states of affairs to which novel laws may govern. And mathematics, while being a useful tool, is not the mirror of nature. There's no mathematical object which is the perfect mirror of nature. And we would argue that if you take seriously that the present moment is part of the natural world that naturalism is supposed to describe and account for, then there can't be a perfect mathematical mirror of nature, because no mathematical object has the property of existing moment by moment to moment to moment. There are no present moments. There's no flow of moments in any mathematical object. So that's naturalism too. Now, that's the scientific claim of the book, and that's what most of the book develops. Since I thought I hadn't taken on enough risk in writing a book that argues that there are no timeless truths, I thought to give myself the challenge of writing an epilogue where I addressed this transition from Naturalism 1 to Naturalism 2 as a human being, what it meant for me in my personal life, which is off the table here, but which I hint about there, what it means for us as a society, which is very much on the table here. I think I just want to make a broad, ambitious claim and then leave the discussion open. So the claim I would make is that it matters. When we think about, and I'll just focus on climate change because that's such an important issue, and it has all the issues related to time, because the issue about climate change is the uncertainty of the future, is it not? The best science will not tell us how bad it will be if we do nothing. Therefore, we face making good decisions about an uncertain future, which is, of course, the situation of human life. The situation of human life is to be balanced between danger and opportunity. And this is just a particularly acute form of it. So when we are balanced between danger and opportunity and the future is unknown, how do we think usefully about the future? And I think if we imagine ourselves living in a cosmos in which novelty is an illusion, agency is an illusion, will is an illusion, there's a demoralization that takes place. There's an alienation that takes place from between our aspirations and our view of the universe we live in. if we imagine ourselves living in a universe in which everything changes and everything evolves, in which novelty is a real possibility, in which the imagination of human beings is an organ that takes advantage of the natural capacity to invent novel phenomenon and for novel regularities to arise, then we may get a moral lift. We may think to ourselves, maybe, even if we can't see how, it's possible that we have the agency, the imagination, the will to invent our way out of the problems that face us. And I'll stop there.
Well, I start from a very, very advantageous position of almost complete ignorance of the cosmology and physics of what Lee has been talking about. So that's very useful, especially to a philosopher. It's never a barrier to philosophical disposition, ignorance. But firstly, I have to say that I find Lee's position about the place of the concept of time in discussion of natural law rather attractive, and insofar as I'm in any position to judge, it looks as though he's issued a challenge to his fellow physicists of a very interesting kind. I do want, though, to register just one or two little thoughts, some of which are tangential, perhaps. One is that, with the very honourable exception of Einstein and relativistic physics, almost all other metaphysical positions which have turned on the claim that time is unreal are in fact very unattractive ones. In almost all other cases, the idea that time is an illusion, that it's unreal, that genuine reality is atemporal in some way, is associated with a tradition of metaphysical thinking which is at odds, in fact, with a lot of other thinking in the history of philosophy, indeed the history of thought in general. For example, it's an assumption of history that there is time. It is an assumption of our psychological interpretations of the self and of our relationships that there is narrative structure to them, and that involves time. So it may very well be that there is a disconnect, in a way, between how we think about lived reality as being something essentially time-bound, with all the tragedy of aging and the delight of the recurrence of seasons and so on, and the kind of view, the Neoplatonic view or Platonistic view about the unreality of time. So one thing that perhaps one might guard against a little bit is to equivocate on the idea of time and timelessness. Here is a timeless truth I'm just about to tell you, and I'm sure Lee will enjoy this, and you will notice it takes the form of a conditional. If we understand by 1 plus equals and 2 what we currently understand, then 1 plus 1 equals 2. Now that is a timeless truth just by definition. So there is a sense in which you could nominate, in fact, a whole class, in fact, an infinite class of timeless truths in that sense. They're not an interesting sense from the point of view of physics and of natural law, but it's really very important to note that there are uses of expressions like timelessness, and truths can become permanent. I mean, it is now a truth forever that this meeting occurred on this date, at this time, in this place. Nothing is going to change that, however much future generations may wish to rewrite this out of horror at Lee's proposals. Nevertheless, it is now a truth forever. So that there are senses in which one would want to retain some use for notions of timelessness and permanence. But they don't influence, they don't affect really what Lee has to say. And so for that reason, one can, I think, be very attracted by the idea that here is an exciting new proposal which needs to be examined by Lee's professional colleagues and put to the test. I mean, one thing that Lee does say in his book again and again is that good science must issue in predictions, and the predictions must be testable. And there are a number of things suggested by Lee in the book which would issue, I think, in experimental tests. And so the proof of the pudding will indeed lie in those tests, I think. My final two little comments about it are these. Is it possible that our experience of time, the felt reality of the passage of time, is something that we are taking too far in reading into how things might be in the structure of the universe at very different scales? So that's a question. It's not a criticism, but it's just a question I think that one needs to address. And finally, there is one thing that we may come back to a little bit later, and that is that Lee is very scrupulous throughout the book in saying he's a naturalist of type 2. It's a bit like having a blood type. So I'm a naturalist of type 2, and this is a temporal naturalist, that there must be prediction and there must be testable prediction in this theory. And then you very, very slightly disconcert us towards the end of the book, Lee, by saying that the phenomenon of consciousness is not one that can be inferred from anything that we know about the central nervous system, and so all of a sudden we find ourselves on the blurry margins of naturalism there, and perhaps later on you'll say something about that.
Please do.
What I find fascinating in terms of the message from Professor Smolin's book is that in some ways I was wrong to be criticizing economics for borrowing so heavily from physics. Because the fact is, the issue wasn't the fact that economists were borrowing from physics or mathematics, it was rather they were borrowing the wrong type of physics and mathematics. They were borrowing this idea of the universe being full of eternal, timeless truths that essentially could be uncovered and applied to the way that money worked in a rather crude, rudimentary fashion. And so in many ways, I think his work really does challenge us to think not just about the import of quantitative techniques into the world of money and policy making, but also to reflect on what we can perhaps learn from his vision of physics and this new appreciation for time. If it's true that in fact physics can, or physical laws can evolve and change through the passage of time, and if it's true that essentially physics is path dependent, which I think is perhaps the most important word of all in terms of trying to communicate these ideas to lay people, i.e. human beings can learn from the past and respond and move forward. The natural universe can also learn and change. Each time a law of physics takes place, it changes things and essentially creates some form of, if not evolution, then adaptation or change. If that is the case, then that has a lot of implications for how we devise policy, in terms of running an economy. It has implications for how we try and make sense of markets. It has implications for simply assuming that what's happened in the past will be the perfect guide to the future. So I'll just end by saying that one of the most inspirational things that I find in his book is this point that actually we don't all need to live in extreme silos in terms of academic and intellectual thought. We don't need to assume that there is such a deep divide between the social sciences, between relativist, context-bound anthropologists and the hard sciences. We can all learn from each other, and we all need to learn from each other, not just to try and look afresh at the world of physics, but also to look afresh at the world of economics too. And frankly, if there was ever a really timely moment, not to crack a bad joke, to be doing this, it really is today, when the Western world is confronted with so many very, very profound, intractable economic challenges, for which, frankly, the past is not a very good guide for either predicting the future or trying to fashion policy today.